Thank you. My name is Andrei Rubachevsky. I just finished, I think, the most complex part of my presentation, connecting my laptop. Second guy, Mark Drans, he's not here, but all the work that I will present is actually being developed and supported by his group at the RIPE NCC. So, RIPE NCC Information Services, and probably many of you have heard of those services, and we hope that some of you are using some of the tools that I'm going to present. And this is just a quick update on those tools and services. And we're also going to introduce some new and probably useful and cool stuff, and would like to give you an update on this as well. So we build our information services on three main pillars, and those are TTM and Test Traffic Measurement Network, built of 80 Stratum 1 synchronized nodes that spread around the globe and doing connectivity measurements among themselves. The second one is Routing Information Service, which you can see is a distributed looking glass with history. And the third one is DNSMon, a tool that allows to monitor performance of core DNS servers around the globe. The peculiarity of the Test Traffic Measurement Network is that the whole network is very well synchronized. In fact, every node is a Stratum 1 NTP server because it's connected to a GPS antenna. And that allows us to perform one-way measurements of traffic, of packet delay, lost, and jitter. And all the data that measured among those nodes is collected in central place and available through various tools that you can query this database and present this data in various forms. I can show some of those. Well, if you look at the map of TTM, you would see that mostly it's Europe-centric, but we're also very interested in actually increasing the presence of TTM probes in the Americas, Africa, and Asia Pacific region. This is what one would expect from a traditional TTM service. It allows you to measure connectivity from your network to other networks like network B and network C, also to some reference points with very good connectivity, such as big internet exchanges that also host TTM probes. And it allows you to look at this data over time in form of graphs of connectivity, packet lost, jitter, and distribution of jitter, for instance. It also allows you to use trace route with history to track routing changes across certain links to certain measurement points. We are trying to improve user interface and the way we present this data, and mapping TTM data to Google Maps is one way of doing this. And using this interface, you can actually also access graphs on packet loss, delay, and jitter. And though geolocation service can play jokes sometimes it gives you some insight into interesting patterns you have with your connectivity. But what I told you so far was about traditional TTM network. What we are doing right now, we're introducing so-called ad hoc tests and ad hoc experiments, which actually transfers TTM in a general purpose measurement platform. It basically allows you to measure something beyond just connectivity, just packet loss. It allows you to measure performance of certain applications. And the idea is pretty simple. It allows you to define a plugin or a test procedure using user configuration interface, deploy this test procedure in the TTM network, do the measurements, collect them, and present in a way you want it to be. And a practical example, for instance, it allows you to measure a web application, how it's seen from the TTM network. Here is a user interface for those ad hoc tests. Well, this particular one actually measures web application. It's called HTTP plugin. We have a few predefined plugins developed. And this interface allows you to specify for how long you would like to run this experiment, what's the frequency of this experiment, what's the region you want to see measure performance of your application from, and of course the URL of your web server. That's how you can see the results. Well, in this particular, we monitored one of our web servers from 3 locations in European region, and you can see, well, it's not uniform really. It also allows you to monitor connectivity over IPv6, provide that your service is available on IPv6. And just before the RIPE meeting in May, last RIPE meeting, we measured performance of our web server, ripe.net, for quite some time, looking at how our web service looks from IPv6 world as compared to IPv4. Well, you can see some difference. And though the legend is not very readable, I guess you understand that RAD stands for IPv6. The next platform is Routing Information Service, or RIS. As I said, one can look at this as a looking glass with history. We collect BGP updates from about 600 peers from 15 locations around the globe, and we keep them in our database. And database is searchable over 3 months, and we also keep raw data forever. And we build quite a few tools that allow to query this database and present RIS data. Well, this is a geomap with locations of RIS route collectors. They're mostly connected to big internet exchanges where we can get many peerings. 15, as I said. One of the tools we built using RIS data is so-called MySN service. It actually allows you to monitor different things happening in routing with regards to your IS. I think some of those things are similar to presented to Cyclops that we just heard a presentation of. So let's log in. Well, another slide. Well, again, the idea is simple. MySN allows you to specify certain conditions, filters, and RIS data will be filtered. Those filters are looking for conditions. If conditions are matched, you, as a MySN user, will be notified. So let's log in and look at MySN alarms. Well, this alarm is actually called an origin alarm. What it does, it allows you to specify a prefix and be alerted if this prefix is originated by someone else autonomous system. Those are some parameters of this alarm where you can specify for how long events should take place before you're notified, how many events should take place before you're notified, and some other parameters. Well, there are other different types of alarms apart from origin, and in fact, you can even specify a regular expression that MySN will match and trigger alarms. Well, here you can assess the triggered alarms, triggered conditions using our web interface, or you can be notified by email and get an email if something happens. We're also trying to collate different data we collect from RIS in one single user interface. We call it IS dashboard. Well, here you can see various data presented related to your IS, such as number of prefixes announced, distribution of prefix sizes, distribution of your IS path to different route collectors, or distribution of transit providers for your IS. Also here on this dashboard, you can see BGP activity. We do similar things for prefix dashboard, we call it, where you can also see some events related to your to the announcement of your prefix, and also stability and visibility of your prefix as it's seen by route collectors. Also, you can see this on the geomap for a particular route collector. Well, there are many more tools, and I will take just a few minutes just to walk you through some of them. All of them are accessible from this web page. Prefix in use, it allows you to see when last time this prefix announced and who announced this prefix. IS in use allows you to see when the last time IS was seen on the internet, and the IS path, the peers that were announcing this IS to route collectors. RIS whois, and this it has a standard command line whois interface. It's useful for scripts that can use this service. It actually presents information about a particular prefix in pseudo RPSL form that is recognizable by some route configuration tools. A nice tool that visualizes BGP activity called BGPlay, which is developed by Roma Tre University and is hosted on our website, also using RIS data. And of course, we produce several reports that are similar to those produced by other projects like Route Views, and they're available from our site as statistics. Based on RIS data, we also provide service to several regional internet registries such as APNIC, LACNIC, and EFRINIC. Where IANA allocates a new /8, we deborganize this /8, meaning we announce a few prefixes and let ISPs to check if those prefixes are reachable. We also look at RIS data and see if they're reachable indeed. And this is a graph showing visibility of a prefix over time, and you can see that, well, soon after the prefix is announced, already 75% of ISPs see this prefix. I guess that says something about lack of filtering. DNSMon, that's the third service I wanted to give you an update. It's actually a service that monitors more than 200 core DNS servers that provide the service for root, top-level domains, and enum. It's based on TTM network, so TTM runs the probes that do querying of those services, and we collect this data and present in this tag plot that actually allows you clearly see whether the problem is local to your service or it's local to a TTM probe. For instance, if you see a horizontal red line, it's probably a problem with a probe, because the y-axis is its number of probes, or probe number. But if you see a horizontal, vertical line, that may be the problem that, like, very close to your DNS server. So this service is used and appreciated by DNS server operators. But you can also look at DNSMon from a different perspective. Being a TTM box owner, you can actually measure connectivity from your box to those 200 plus core DNS servers, which actually will represent your connectivity to the rest of the internet. And again, you can look at this from in the form of stack plot and see the proximity of problems as related to your TTM probe. Well, and as a conclusion, I would like to give you some URLs and some pointers and some credits. Of course, as I said, those tools are being maintained and being developed by the team which call Information Services Department at the RIPE NCC. If you would like to learn more about routing information service, TTM or DNSMon, those are the URLs. And based on data collected by those tools, we also at the RIPE NCC did some interesting analysis of recent events in the internet, such as cable cut and YouTube hijacking. We have a science group at the RIPE NCC that does analysis of this data, and those reports are also available from RIPE NCC website. And that concludes my presentation. Thank you.
Thank you, Andrei. Any questions?